Hey everybody, this is Larry, this is me going Q3 of the bi-weekly contest 165. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. This one is generated schedule. Honestly, I had a lot of issue with this one, but at least two of the wrong answers were just me being dumb, so we'll go over it right now. First way that I was being dumb was that I just forgot the home and away thing. And like I just didn't swap them. I knew what I wanted to do, I just didn't implement it when I submitted. And the second thing was that I had my notebook here with pencil and paper, and I did the n is equal to 4 case, 4 teams, and I thought it was possible, to be honest, because I wrote down half the schedule and I forgot. Oh, I didn't forget, but I just assumed that the reflective side, right, meaning that the home away thing just flip it and be fine. But it turns out that it is not possible because of just the way it is set up. And yeah, so 4 teams are not possible. So then how do you get the rest? I heard that there is a greedy solution, but I didn't do it that way. So if you need a greedy solution, then definitely, well, maybe check out another video or solution, because I didn't know how to prove it. But the way that I did do it was with randomization. Why does randomization work? No idea. But why do I have an intuition for randomization? Well, the intuition is that for big n's, right, for n is equal to 50, say, and this depends on the way that you randomize, etc., right? But I thought that the way that I did it in a quote-unquote greedy way is just that given a list of schedule, I would find a place to insert the current game, wherever that is, and then, well, keep going, right? Like the earliest that we can insert it doesn't really matter. So the intuition behind that, behind that randomization or greedy, well, the greedy, it just makes sense, right? In the sense that it could work, not that it always works. That it could work because, well, if you just keep on inserting games somewhere, it should be good, right? And the intuition that it probably would work is that for large ends, big enough ends, you just always have enough games to squeeze it in, right? And oops, how do I? Oh, there we go. Oh, well, not this one. The intuition for me, for like, say, I don't know. I mean, n only goes up to 50 in this case, but we'd even just, you know, pick a straw man that's a little bit bigger. Then you have like n is equal to 100. You have like one, I don't know, just like 0, 1, 2, 3, 4, 5, 6, 7, yeah, 8, 9, dot, right, all the way to, I don't know, is it 98, 99, something like that. So then now you just pick a number, or like any other pairs, like you say 8, 0, 5, right? Well, if you have 100 or 50 pairs, this only at most gets rid of 4 places, right? Because 0, well, in this case 0 is, let's just try, I don't know, 10, right? 5 and 10. So the game is, the next game we're trying to insert is 5, 10, and in theory, you know, the 5 would means that you cannot insert it between these 2 places, and the 10 means that, well, if there was a 10, you cannot insert it before this game or after this game, so 2 places, and you have 50 of them, so you could obviously always find one. There's no probability here, right? You just find a greedy one, and it always exists pretty much, right? Like there are 46 places, and then same thing for every other number pretty much, right? Like, you know, like even if you have, like, the only way that you cannot find an insertion is if you have I don't know, like 40 10s in a row or something like that, right? Which is what are the probability of, like, 40 games with the player, the team 10 or something like that in a row, and what are the odds of that, right? So that's kind of the intuition. I'm not saying it's a perfect intuition, but the key thing about randomization is the odds don't have to be that good, right? What I mean by that is that even if you have a 50% chance, even if we have a 50% chance of succeeding, what does that mean? We only have, it means that on average we only have to do it twice. And also it means that, let's say, I don't know, that means that if you do it 50 times, you would have 1 minus 2 to the 50 chance of succeeding, right? So those are just like random, you know, like examples of the intuition, right? And I knew that as a result of this, as the way that we structure it, for smaller ends, it would matter more. And actually, I honestly do not know what the odds are. I also tried to do this offline, as in like pre-generate the answer, but apparently for n, apparently it just, I guess n equals to 50 is, n is equal to 50 is 50 squared, so 2,500 copies, and then you kind of increment that from 5 to, so that's a lot of things, and apparently it's too big to share or whatever, to send to Leetcode because it just crashes. But in theory, you know, you should even pre-calc it, and that's basically the idea. I think if you have like n is equal to, well, 5 is the smallest one, so you have 0, 1, 2, 3. Let's just say you do an order, and then now you have say 4, 0 or 0, 4, then there's only one place, right? So in greedy way, you always just put it in, and then maybe you do what's next? I don't know. Let's just say you have a really bad luck and you go 0, 0, 2, and then this is not possible. So then you just randomly shuffle the thing again and then try again. I honestly do not know what the n is equal to 5 cases, but maybe as a problem, as a part of this video, we will see. But that's basically the intuition behind randomization, right? Okay, and we'll go over the code real quick, and you see that I actually pre-cached this so that we don't do anything too funky, just in case they do something weird. But yeah, as you can see, we make an attempt, and I have a case for if it doesn't finish, and if it doesn't finish, we try again, and then we return answer. Right, and that's it. And the code here looks a little bit messy, but we'll go over it, right? So this is P for number of pairs, or maybe G for games, but I did pairs, right? I did I and J in no particular order because my idea here is that after we finish, we just rotate it, right? The second time we see a game, so I don't have to worry about like more if statements about stuff like that. Though I would say, but one of the wrong answers because I forgot to what you might call it, flip it. So okay. In any case, yeah. So I did 1,000 iterations of. Oh yeah, one more. I don't know if it's an optimization, but one more thing that I did is that if we had numbers left over, we just do the loop again. But that's it. For every pair, we look at the number of current things, and if it's 0 items, then we just insert in the beginning. Otherwise, we just see if we can insert it at location 9. So literally, we go from left to right. We see, can I insert it here? Can I insert it here? Can I insert it here? Dot, dot, dot. And if we can, then we just insert it and break. Otherwise, if we can, then put on leftovers, and then we just kind of keep going until we're done, or 1,000 iterations, whichever comes first. Yeah. And 1,000 is just a random big number. There's no significance to it because like this is randomish. Yeah, and that's it. Every time we insert it, oh, and this is the thing where I was saying about we flipping the games from home to away so that, you know, it's consistent. And if we do still have things left over, we return -1, and that's it. Yeah, and then we just keep going, like I said, and yeah. For fun, let's actually, yeah. For fun, let's see what are the probabilities, right? So let's just say we do it 1,000 times. Let's take away the cache real quick. Calc 5, because I think 5 is, like I said, the smaller it is, the harder it is to randomly squeeze things. So we'll try it, right? So R is equal to this, right? If length of R is equal to 1, then we do wrong is equal to else correct. Right. It's gonna take a bit to run. Where's my water? Maybe even times out actually. Oh, huh. That's actually funny. Oh, no. I'm wrong. Sorry. Because I did this. This is with the while loop. So, yeah. So I'm wrong. This should be attempt. Okay. Also should be faster as a result. Oh, did I run out of water? Yeah, as you saw, it's was it 200 and something? Right, hang on, sorry, getting a water. I guess I ran out of the other water. Oh no, it's right here. I lied. Okay, so I don't need this water. Yeah, so I overestimated at 50, right? Which is still, I mean, it's not great. It's just that the math is much more obvious when it's 50. But as you saw, it was like 28% or something. We could do the math there too, right? But I knew that as n gets bigger, it gets easier, right? This is about 30%. So let's try 6, right? Let's try 6. And there's like some central limit theorem thing. It's equal to 30%. 6 is already at 60%, right? As you saw, right? We'll run it again. I mean, obviously this is a little bit, you know, it's not precise, but 60%, right? 61. For completion, we'll just do 7. Seven's no, that's really 1,000 seems pretty. So okay, so I mean, as you see, like even so, it's only an issue with 5 and 6, really, right? It's already at 1,000 or 1,000. Am I? Huh. Yeah, and one's pretty fast too. So then, like now, if you do just 15, is that also 1,000? That should be, right? Yeah. So that means that okay. So honestly, it seems like we can, if you did it in this weird random way. You can just cache 5 and 6. 6, kind of the math is obviously here. I mean, 60 is better than 50, obviously, but you know. So that means that, okay, even if we have, what does that mean, right? That means that we have to do it at like 3.3 times, right? You have to, if you did it 50 times, what does that mean, right? It's just 1 minus, oh, I wrote this wrong, actually. It's 1 over 2, or just say 0.5, right? But this is 0.3, which you can calculate with a calculator, that's what I'm doing now. Hang on. 0.3 to the 50 is, I don't know, 7 times 10 to the... right? Oh my god. Oh jeez. But you get the idea. That means that we do it 50 times. This is a very, very small number. Like you could bet your life on it, kind of small number, right? So yeah, that's basically the idea, and that's basically the algorithm, and that's basically the intuition that I was trying to go over. Is that I didn't know what the exact numbers were, and I knew that, but intuitively with big N it is very likely. And maybe if I was more diligent during the contest, but obviously during the contest I'm just trying to optimize for time, and it's okay to, like, if it took me like 10 minutes to come up with this, then it would have, you know, a wrong answer is okay in the sense that like it cost me 5 minutes anyway, right? Or 10 minutes or whatever, right? So yeah, that's it. And I don't know that this is strictly 30%, but you know, central limit theorem, and it's close enough, right? Like you could say it's a little bit lower maybe, but like I said, if you do it 50 times, it'll be fine, right? And then the complexity, if you want to do it that way, the complexity, and you know, let's say you want to do overwhelmingly, so at least 50 times. Well, this algorithm, well, this is an n squared number of pairs, so well, keep in mind that this only is true for the number 5, right? So n is equal to 5. So when you say like n squared or something like that, it's 5, right? In case, so it's not even the 50, because 50, as you see, it gets it right on the first time 100% of the time, right? Yeah. So we don't even have to do anything for that. But yeah, so 5 squared shuffle is just also 5 squared because that's the size of the shuffle. Yeah, and this is all 5. Well, this is all 5 square time, or right, and yeah, and insert is also n square, if you want to put it that way, and this is also kind of n square. So a lot of 5 square stuff, but you know, 25th to the 5th, even in the worst case, it's not that bad, and you're only doing it like a couple of times, right? So yeah, at most 50 times. So that's basically my intuition and logic, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and yeah, you could watch me some. Oh yeah, just before I go though, I mean, sorry, I have like some allergy issues. But before I go, I did actually try to do another randomization of just putting it. I mean, the same idea really, but my first attempt was to just put every pair at the end and see if you could kind of like just basically verify whether you could put it at the end. Apparently, that's actually way less probability wise. So that's why I came up with this, because I was like, oh, you just insert anywhere. And of course, you can actually be a little bit smarter with this, right? In theory, if you want to improve the complexity, you would do a linked list insertion instead of an array insertion. But again, at most 25 elements, it's not going to worry me, right? Yeah, or I guess even 2500 square doesn't worry me, so I'm not going to worry about it. And yeah, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you could watch me solve a live done contest now. Bad mistake. I think I'm just rushing a little bit, to be honest. I need to slow down a little bit and think about the cases, because I didn't even catch that until I debugged it. I just didn't. I'm rushing it. Yeah. All right. Well, let's go. Q3. Generate a schedule and teams. Each team tries exactly one match for the consecutive days. No teams plays on consecutive days. And they're not always possible, and it's equal to 50. Okay. If this is this one of those things where only 3 is not working? Right. I mean, okay, so, well, not only, but you have to play every day, or they. What does a schedule look like? Oh. You only play 1 match per day. Okay. So if n is equal to 1, then can n be equal to 1? No. N equals to 2, that is just trivial. Okay. And then 3 doesn't work. But I think if anything that's not 3, you should be able to do, right? Because you always just have rest. But the 2 is that there's a pigeonhole, right? Oh no, 2 either, right? Because then they play consecutive days. So okay, so whoops, that's the way that they wrote it. I mean, it wouldn't be unfair, but it would just be the rules. Okay. And then 4. Let me write it out real quick. Double check. 4 would be 2, 2, 3. Yeah. Okay, and then now what? And then 02, 13, 03, 12. I mean, okay. I mean, this is, and then just duplicate it. It doesn't really matter. Like giant mosquito or something flying around. Okay. The home away team is not, as long as you find symmetry. It's just first half, second half. I don't think there's anything weird. Maybe that's not it though. Is this? Okay, so for every even number, there should be. It's just round robin almost, right? But what about odd numbers? Okay, let's try out the one that they give us. Or actually, I should just do my own, because I think they always give like a shenanigan one. Okay, so 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 2. I mean, I think even is pretty straightforward. Odd numbers, and apparently it is possible. But so 1. 02, 03, 04, 01. Oh, there's a 2 here though. Like, what's a good systematic way? You can't do 1, 3. I mean, you can, but now you have 4 again. 4 has done 0. 4 has to do 0, and then 2. And now 0 goes again. 0 goes to, oh, we done 1, 2, 4, so 3. And then 1 does 4, I suppose. And then now 2. I don't know. I don't know that I see any graph rhetoric here. Am I sure about the even one? Let me double check real quick. Okay, let's say we have this, right? And now we're 1. Oh no. Can I just choose any game? Is it just like naturally greedy or something? Even numbers, actually, I don't know. I mean, I created one kind of, and at least there's symmetry, but it's not quite sure to me how to systematically do it. Can I do it randomized? That would be fun. What are the odds that? Or can we sort? And like, do we need things to be like? Is it actually that probable? Right. Okay. So let's say we have C1, 1, 2, 3. So we have all these things, right? That means that we. I'm trying to think the math on, like, can you keep on building, like, is it always possible to have one if you just kind of, like, in a, what you call it, graph kind of way? What's the one with Euclidean graph? Like, if we just do 0, 1, okay, let's just pick or do you always just like if we just write random numbers, does it always go good? Or does it, like, okay, so now I don't know, so I'm gonna try it out. I mean, I could do it randomly on my paper, but okay, so I know that we could swap do backwards. It's not a big deal, but okay. So then now we go. Yeah. We'll do like a Fisher-Yates thing, right? What is random? Python, math, random. I forget what random index. It's not something that I use that often on random int, rand range. Okay, let's see, what's rand range exactly? I guess it is what it sounds like. For while length of p is greater than 0, index is equal to right? And then now, okay, so then now xy is equal to p of index, right? If x is length of current is greater than 0 and we try again. Otherwise, then now and xy, we want to swap p sub index p of -1 is equal to p of -1, p sub index p dot pop, right? I don't know if this works, so let's YOLO submit. It may infinite loop. I think that's what will break it. Okay, well, I mean, if it doesn't work for 5, it's probably not a good sign. Okay. I was hoping that like maybe there's some like weird property here, but we can actually, yeah, maybe do like a oh, whoops. This should be before the loops. Okay, well, I mean, it doesn't seem like that would work. I was hoping that maybe, like, it's one of those like Euclidean path things where it doesn't really matter. But it seems like oops. Okay, yeah, I couldn't see it. Okay, yeah, so that means that you can get into a place where that is bad. And I know that you have to swap the away to an away game, but that's fine. Yeah, I mean, so in fact, it doesn't seem like it ever works. So, And this one works all the way to, except for the very end. Seems like everything's somehow matched though, except for like this one thing. What if I do insertion sort? Can I do insertion sort? No, because then can you always find a place? Yeah, this seems like it never works. Oh. Okay. Is there like a random shuffle? I forget. Alright, let's try that. I have no idea apparently, so I am just doing random things. Random dot shuffle, right? Okay. If you have to check, I know. If good, then there is like an insert, right? Yeah, okay. I don't use insert very often because oh, wait. Hours were not good. Oh yeah, this is actually pretty. We have to bring it back. Leftover. Wow, leftover is everything, huh? That doesn't seem right. This is good. X is in current. Oh, because we never insert. This should be I plus 1, I guess. What does this even mean? Like, every number should be in one or the other, right? Why not? Oh, good. This shouldn't be a break. This is just. Okay. I mean, that looks good. But no leftovers. Wait, double check real quick. No, this is definitely wrong. In fact, a lot of it is wrong. Or maybe I'm just. Oh no, or that's the leftovers. No. Why would. What? Inserted at I. I think this is inserted at I plus 1. Is this okay? No. Okay, let's see. Why? It's good. You got to force. No. That maybe the end is not quite right. I don't get it. Okay. I am bad at coding. I am bad at coding. 130114, but this is already matched, right? Okay, so if I don't do anything, I insert at the very end. That's what this does. That's where my code is messed up. Okay. Alright. Well, maybe I just need to do something like, maybe I'm just being dumb, trying too much. To make that work. Okay, so now they're leftovers. So that means that is. Well, I mean, everything here looks consistent at least. Can I now do one more loop on the leftovers? Maybe. Is that timeout? Why would it time out though? How can there be? Like, I'm trying to find a case where that is the case. Maybe I just need to also like just be a little bit less lazy and actually figure this out. Though maybe this is too slow. 50 times 1,000. Should be okay. Maybe. Like it should always increment, right? Oh, I'm dumb because here leftover should be I see. Okay. I mean, is it the best idea? I don't know, but it. Oh no. Just when I thought that we got it, we had it like lucky twice in a row or something. Oh, maybe I'm lying. Maybe I wasn't seeing it. Like, see, this time we got lucky. But before, how is this? Maybe we were still right. It's just that we print too much because it took a while. All right, and I'm hoping that for 50 is like in the sense that the bigger number, in theory, there should be more things to squeeze. So 5 may be the worst case. We'll see. All right. Okay, I mean, it gives me something. I don't know if it's right, but it gives me something. So let's YOLO submit this. I actually made a mistake here. Wait, how is this wrong anyway? Oh, I forgot to reword the away games. Okay, that is a stupid mistake. But I also should have just cached this. I think that's the other thing that I should have done. Yeah. Okay. Okay. Yeah. Okay. That was just dumb. I forgot to yeah. I forgot to fix the things. That was just dumb. Okay, that was a freebie. Let's YOLO submit. Oh, does it have to be any way? No, yeah. What? Did I misread this? Do. Why is this wrong? Oh, I'm missing a game. But I thought, did I just get unlucky when I submitted it? Because there are no leftovers. Oh, maybe I lied. Because I said leftovers to empty and then I break. Okay, so I did lie. Okay, I lied to myself. Okay. But it seems like for anything that's... well, actually, it's... But you could see that... okay, so it's not going to work, but we do have cases where it does work, right? So we can actually just save them down. Okay. Okay, so then now, maybe we go actually we put that there, right? Okay, so then now we want to do an temp of n. If length of answer is, or maybe just do I think I'm doing this wrong in the caching. Because I think what I should do is do it offline. Oh, what am I doing? I mean, of course this is going to be yeah. That's what I meant to do. Okay. Looks okay, maybe. I'm going to YOLO submit one more time. I don't care about a wrong answer. I may time out. But I think what I should have done is do this and then if it times out, that's fine. It is a very annoying problem anyway. But we can, yeah, maybe it times out. For 4, huh? 4 has an answer, right? I mean, it actually is riskier for smaller numbers, so that's why I'm actually curious. It's 4. The sad thing about this is that I wish I got it wrong. It tells me the answer for 4 because I think it's possible, right? I wrote it out. I mean, maybe not with this algorithm, but okay. I didn't do it backwards, so maybe that's the reason. Okay. Oh no, that's 5. Okay. Oops. 1, 2, 3. Yeah, no, I mean 4 is definitely possible. But okay. Let's say for I in range of 51. Let's just say let's do this anyway. I mean, I think we got it. It's just okay. I'm spending a lot of wrong answers, but that's fine. So we start at 4. Print I calc I. Let's see. Maybe I should have done this at like 6 or something. The 4 thing is a little bit weird because 4 we can do manually anyway. So 0, 1, 2, 3, 4. Right. So let's start at 5. 5 we got. Okay. Right. So 4. Let's just write it manually. Sorry, we're done. Oh wait, maybe I'm wrong. Maybe 4 is not possible. I thought you could just flip it, but then now you have 0, 1, and maybe I'm wrong. Okay, so that's why it's infinity. Okay, maybe that's fine then. Maybe I should still pre-cal though. Pre-cal dot append calc of I, print pre-calc. Oh, because this is 4, so it terminates early. So okay, let's just do 5. Okay, as long as this doesn't say, oh, it does say. Okay, I'll run it offline. Sorry, friends, that you can't see. Oh, It adds Leetcode, so I had. Ah man, I forgot I add all these headers, like from memo and so from. What is it? Where is cache from? I forget it nowadays. Python memo library, right? Memorization library. LRU cache. Okay, fun tools. Import cache, right? List. It doesn't write anything. Oh, I have to write solution.generate schedule. Whatever. I have to return self. Okay, now I have a bunch of stuff. Alright, let's copy it to thing, and then now maybe here. Yeah, okay. And then now, what did I click on? Unknown network error. That sounds right, but okay. And then now we want to say return pre-calc of n. Right? Is this too big? Maybe this is too big, which would be very annoying actually. Maybe that's why. Okay, so then we cannot pre-calc this, or not like this. Okay, in that case, oops. Then I guess we have to YOLO this one more time. And then I guess I thought 4 is possible just because I did half of it and then I didn't realize. YOLO submit. Okay. I mean, really annoying problem. But I really thought that. Yeah, I mean, I thought 4 was possible. I guess that's cost me a couple of wrong answers. But alright, we have 47 minutes left. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye-bye.